Patients with unilateral facial paralysis experience impairment of facial activity on one side of the face. They cannot correctly control their facial muscles for daily activities, such as blinking. Our proposed device aims to detect a patient's blinking from the healthy side of the face and synchronously deliver an electrical muscle stimulation current to the paralytic eye to restore blinking functionality. Here's a schematic diagram of the block diagram of our design consisting of 3 parts: data acquisition, data processing, and output. We are using 2 pairs of electrodes. One pair of electrodes is placed vertically to measure the lateral electroocularogram EOG signal as the potential difference occurs between the electrodes. Another pair of electrodes is placed horizontally to record the horizontal EOG signal. The vertical EOG is mainly used to identify eye blinks. The vertical and horizontal EOG signals are then pre-processed and amplified using a bit-alino electroencephalography EEG sensor. The MyRio takes the information from the EEG sensors through analog input, which are multiplexed to a single analog to digital converter that samples all the channels. Next, we are using LabVIEW to provide a graphical programming environment for signal visualization, processing, analysis, and hardware control, such as the LED on the MyRio. We can visualize the raw and filtered EOG from the vertical and horizontal channels, as well as the simulation of the output biphasic pulse trains on the front panel. This is an overview of the block diagram on LabVIEW that contains all the graphical source code. The analog output channel on the MyRio is used to deliver the biphasic pulses. The multimeter, which is put in series with the circuit, reads the current in the circuit to verify we are getting our desired output. However, considering ethics and safety regulations, we are only able to use a simulation of the output and measuring the current using an LED and multimeter as indications of synchronous electrical stimulation to the paralytic eye. Here's how our device works. When the patient blinks, a huge deflection of voltage in the filtered EOG signal is identified on the front panel. The huge deflection of voltage exceeds the threshold parameters set, which lights up the Boolean indicator, which represents an eye blink. The pulse train is generated at the same time, which produces a current output that stimulates the orbicularis oculi muscle, the muscle responsible for blinking. The current that is produced is then indicated by the multimeter. In the future, this device needs a balance between effectiveness and comfort. Lower currents are more comfortable for the patient but are less effective at eliciting complete eyelid closure. Higher currents are more effective, however, but cause more pain. This issue could potentially be addressed by decreasing current but increasing frequency and pulse width. Moreover, due to the low output current drive of the MyRio, a current stimulator amplifier could be implemented in order to produce the required current.